To compute this limit, we start by attempting the direct substitution property and substituting 0 for h. But actually in the numerator, you get 3/5 minus 3/5, and that's 0, and in the denominator you get 0. And so we can't tell yet what this limit is. So the thing to do is to change that expression with algebra until we can use our limit properties to evaluate. And so what I'm going to do is start by, I don't like compound fractions. I'm going to start by combining those two little fractions in the numerator by finding a common denominator and subtracting. And so I've chosen to do what's usually called the bow tie method. I multiply 3 times 5 minus 3 times 5 plus h. And it's all divided by 5 times 5 plus h, and that's all reflected right here. And I've copied down this h here. I haven't done anything with it yet. Next, I'm going to do two different things. The first thing, if you can see, is I multiplied the 3 times 5, and I distributed this 3 over the 5 plus h. And so what I get is 15 minus 15 minus 3h. Second, what I've done is I've rewritten this quotient right here. And so you know when you're dividing fractions, you're supposed to multiply by the reciprocal, right? So think of this h right here as h over 1. And so this fraction can be rewritten as a product. And that product is the exact same numerator times the reciprocal 1 over h. So that's a lot of algebra right there in that step. Next, what I'm going to do is some obvious simplification, right? 15 minus 15, that's no big deal. And I'm also going to combine those two denominators. I'm not going to distribute anything, I'm just smashing everything together. Now, this is very nice. Can you see the two h's, the one on the top and the one on the bottom? So now this rational expression has a common factor on top and on bottom, and I can use the cancellation property to get rid of it. It's now time to actually do the limit. We haven't even done the limit yet. So now, when I attempt to do the direct substitution property, when I substitute 0 for h, I actually get a real number. And so that's what the limit is going to be equal to. This is the moment. This is the moment from here to here. This is when the limit actually gets done. You substitute 0 for h, and you get negative 3 over 25.